Hello students, so now we are going to start the topic impedance. So let's start this topic. Impedance we are representing as a Z. So what is impedance? Impedance is the opposition offered by the CR circuit. Like in previous section we have saw that individual if C circuit and R circuit will be there. So how we can actually calculate the value of a reactance like a C or C, there will be a capacitive reactance. We heard. Similarly, if we just take CR, complete CR circuit. So for that scenario, if we want to just calculate the value of a reactance or the opposition which is offered by the CR circuit, so that is called as impedance. That is Z is equals to Vm by Im is equals to under root R square plus 1 by omega C whole square, which comes is equals to under root R square plus xc whole square, where Im is the maximum value of a current given as its impedance. Its unit and dimensional are same as that of a resistance. The current in the circuit is ahead of EMF by the phase angle phi, which is given by tan phi is equals to xc by r, where phi is equals to, we can calculate this value in the tan inverse, like tan inverse is equals to phi is equals to tan inverse xc by r. So AC through an inductor L and a resistor R in the series. This is a circuit diagram. As you can see over there, students, there will be a resistance R is present over there. And this is the symbolization of the alternating current of AC. Okay. So this is a what? Students, as I told you in the previous class, that AC symbolized not A dot C, not AC, that is simply AC. Understood? So the previous one which I represented, that was a not correct. So this one AC. Understood? Alternating current. Alternating current. Symbolization for the potential. So Vm representing the maximum voltage or the peak voltage. Similarly, what I am representing the maximum voltage or a peak current, maximum current or a peak current. Understood? So consider a pure inductor of inductance L and a resistor of a resistance R connected in series. So as we have taken already R and inductor L. Okay. These are both in the series connection. As you can see, end by end connection are there. So V is equals to Vm sin omega t, as you can see. At any instant of a time t, let the current in the circuit be I. The back EMF developed in the direction or like inductor L di by dt opposes the applied EMF V. So effective EMF in the circuit becomes V minus L di by dt. It should be equals to the product of a resistance and current, that is IR. Hence V minus L di by dt is equals to R. The applied AC EMF has an instantaneous value V is equals to Vm sin omega t. Therefore, Vm sin omega t is equals to IR plus L di by dt. The current I at any instant of a time small t is given by I is equals to Im sin omega t minus phi, which is the second equation, where Im is the maximum value of the current, which is given by that Im is equals to Vm divided by under root R square plus L omega whole square is equals to Vm divided by under root R square plus XL square. So we know that XL is the inductive reactance. As in the previous class we have studied that XL is equals to omega L. So instead of like L omega or omega L, we can put the value of XL. Its impedance Z is equals to Vm by Im is equals to under root R square plus L omega whole square is equals to under root R square plus XL square. Now, the current in the circuit is lagging behind the EMF by the phase angle. Phi is equals to tan inverse L omega by R or a tan inverse XL by R. So from the equation 1 and 2 which we studied recently, so that will be voltage or EMF lead current by the phase difference phi. The phasor diagram for LR circuit represented as this. Because here, as we can see, voltage is leading, or we can say that current is lagging by the phase difference pi by 2. So there is a question for more understanding that how much you have studied earlier, have you actually get knowledge or not. So the first question is the EMF and current in the circuit are such that E is equals to E naught sine omega t and I is equals to I naught sine omega t minus phi. This AC circuit contains L or R, R and C, only R, only C. The correct answer for this question is, as we are studying, R and L. Next question we have, in an AC circuit having resistance and capacitance, EMF lead the current, current and EMF are in the out of phase. Both the current and EMF in the phase or current leads the EMF. So the correct answer for this question is current lead the EMF. So this is all about for the today's class. Thank you for watching this video.